Assalamualaikum and a very good day. Today we're gonna start the second chapter with this image enhancement. Okay, the main objective of image enhancement is to process the image so it can make or produce the image which is more suitable from the original image for a specific applications. So in other words, sometimes when you process the image, okay, you want to produce or like I said in the previous class, the purpose of image enhancement is actually you want to improve the image in terms of the appearance. Okay, that is one of the purpose of image enhancement. Another purpose of image enhancement sometimes is the output of the image enhancement is not for the sake of improve the output image in terms of appearance or to make it more pleased by your naked eyes, but it's actually is for to make the processed image suitable to be used for a specific application, which is the big system that are like we have mentioned before, such as a computer vision system, because sometimes you need an image enhancement to enhance the image in terms of removing the unmeaningful information and just retain the meaningful information. That what is the meaning by meaningful information there? The meaningful for the next process in the sub process for each and every block. So for example, like face recognition, okay, might be the next block in your computer vision, you want to extract some features. So and then of course your feature extraction module required a certain image, and for example you want to have a certain pixels, you want to have to retain certain pixel, and you want to remove a certain pixel because a certain pixel might interfere the system. So that is where actually the image enhancement will give a lot of benefit. Will give a lot of benefit to that system. So that is also can considered as image enhancement. Okay, but before we go further, okay, let's go to this whiteboard. Okay, this is the overall things that we later discuss about the image enhancement. If you talk about the image enhancement, okay, it's divided into two categories. One is a spatial domain, image enhancement in spatial domain. Another one is image enhancement in frequency domain. And then in image enhancement in spatial domain, it divided into two, okay, which is point processing and neighborhood processing. Okay, so this one we learn in this chapter. Okay, this one we learn in this chapter. While neighborhood processing we will learn in chapter 3. Okay, and then we also have the image enhancement in frequency domain, which we learned in chapter 4. Okay, what is actually image enhancement? If you talk about the terminology in one-dimensional image, okay, I let me go to the next whiteboard, which is this one. Okay, if you remember in one-dimensional signal processing, you have learned some kind of this block over here. Okay, and you can see that when you process certain image in time domain, okay, what we call as a time domain, okay, doesn't matter is it a analog signal or digital signal, both is actually is a time domain. Okay, this is because when we use a notation when you are use a notation in small alphabet, okay, when you are using a small alphabet, that is represent the time domain. Okay, if you represent it in, let's say, something like this, okay, a big alphabet or capital letter, then it represent the frequency domain, if you remember. Okay, if you put anything like this, okay, it represent the frequency domain. While if you use the X and Y like this in small alphabet, then it represent the time domain. Doesn't matter is it analog signal or digital signals. Okay, again, just to differentiate between a digital signal and analog signal is that in analog signal you are using T represent time domain, while in digital signal you use N there to represent digital time domain. And again, of course, if you talk about one-dimensional signals like this, again, the horizontal axis or the horizontal axis should be time. Okay, so that's why when you are directly processing the image without converting into frequency domain, then it's called as a processing in time domain. Okay, you are processing in time domains, which is something like this. So if you talk about image, okay, let's go to the image again. How we draw the image in the previous lecture is like this. Okay, so we have XY plane. Again, this is your horizontal axis, this is vertical axis. Okay, however, in image, okay, we don't have any time domain. The XY plane here or the horizontal axis here is called, remember, we call as a spatial, or if you talk about the resolution, that is we call as a spatial resolution, which is why this terminology happen for image processing. Okay, if you learn digital signal, one-dimensional digital signal, you learn about processing in time domain. Actually, that is similar to spatial domain in image. While if you talk about frequency domain in one-dimensional signals, it's also similar to frequency domain in two-dimensional signal or image. So if you go back to this thing, back to the overall thing about the image enhancement is actually as processing the two-dimensional signal. Okay, just to make you don't confuse between image enhancement and processing in one-dimensional signals. Okay, in one-dimensional signal they don't use the term in enhancement. They are just do some process in time domain as well as frequency domain. But in this class, that word processing have been changed into enhancement. Okay, that is for the purpose of so it's the word is more meaningful. Okay, now we have objective. We are not just processing the image, actually we are processing towards enhance the image in terms of improving the appearance of image, or maybe to make the image more suitable to the certain application. Okay, that is what we call as image enhancement. And then again, image enhancement is divided into two categories, which is spatial domain, which is like time domain in one-dimensional signals, and then we also have a frequency domain, okay, which is similar to frequency domain in one-dimensional signals. And then in this chapter we more focus on point processing. Okay, in spatial domain it divided into two, which is point processing and neighborhood processing. Now let's focus on this chapter, which is point processing. Okay, the previous discussion explained everything in this slide. Again, the approach is divided into two: spatial domain and frequency domain. And spatial domain, you are direct manipulation on the image, while frequency domain you must convert into Fourier transform to obtain the frequency component before you can process the image. And for image enhancement, is the visual evaluation is done by the viewer, and the process of image enhancement is we call as, like I said in the previous lectures, image enhancement is a subjective process. We don't have any figure to evaluate how good and the process is process the image. Okay, it depend on by your naked eyes. If you feel that the output is good, then the process is the image enhancement that you do is good. Okay, it's different from the next chapter which we learn in chapter 6, which is image restoration. Okay, for image restoration, is the one of the significant difference between image restoration and image enhancement. Image restoration is an objective approach or objective process, okay, which have some systematic approach in enhancing the image, while the image enhancement, they are actually under the subjective process, where it's even the evaluation process to observe how good the process is through the subjective evaluations. Okay, these have been discussed before. The same things. Okay, spatial domain and frequency domain. Okay, and this just some reminders there. Okay, so far when we spoke about image gray level value, we have said that they are arranged from 0 to 255, which is the intensity level resolution by default is 8 bit per pixels. Okay, and then okay, sometimes you will find out even by default the value is 0 to 255. In certain application, they try to normalize this from 0 to 255 become 0.0 to 1.0, meaning that they normalize the value. Okay, again 0.0 is black, 1.0 is white, and then you have a floating numbers within 0 to 1 to represent the gray level or the gray values there. Okay, it actually is the same, because some in certain programs or in certain programming language, they use this representation to represent the intensity or the color levels there. Okay, this is the some basic of okay, this is the formula. Okay, GXY here is the output after you do some enhancement, and then FXY here is your input image, and then T here is called as a transformation functions. Okay, just remember that this is transformation functions. Transformation functions, where this is the function that will enhance the input image of FXY over here. Okay, and GXY is the output after you, or the output after you execute this transformation function T to this input image F. Okay, so let's go back to this whiteboard before we go further. Okay, that's why I draw the whiteboard in this way, so you can relate with your previous course, which is this one. Okay, so you can see that okay, in signal and system or control system, I think I just remember that there are two courses that you learn analog signal, which is signal and system as well as control system, and then this is how you represent the block processing. Okay, where H over here, HT over here represent the block processing, where the output is Y and then the input signal is X. So in general, they call this one, H here is your transfer function. And then when you go to the biomedical signal processing or digital signal processing class, of course, now T become N, just to differentiate between digital and analog. And then the Hn over here is called as a system function. Okay, I think most of the book in digital signal or biomedical signal processing, they call it as a system function. Okay, you can see that is the relations there. Now, okay, in this course you learn about you learn in this course, which is biomedical image processing or digital image processing. Now the H become T. Okay, this T over here is called transformation function. Okay, just want to relate this transformation function with your previous course. Now the relation is there, meaning that now we are doing it in the block processing. You could find out that actually there's a similarities there. Okay, that is why like I said before, when you learn image processing, actually you are also revise your digital signal processing class or control system class, because signal and system class, because actually they are belong to the same family, which is signals. Okay. Okay, the difference is just the transformation function right now are processing a two-dimensional signal. So that's why now you have the fxy over there. Okay, the operator T is applied. Again, this is the same things that I mentioned before. Okay, so now what is the difference between the point processing and neighborhood processing? Remember here, like I said in this whiteboard over here, okay, image enhancement in spatial domain is divided into two. Okay, the one that we will learn in this chapter is point processing, which is this one, point processing. But spatial domain is divided into two, which is point processing as well as a neighborhood processing. The neighborhood processing we learn is in next chapter, while point processing you will cover in this chapter. So the difference between point processing and neighborhood processing is the transformation function itself. Okay, as you can see, why they call it neighborhood processing, why they call it point processing, is because of transformation function. For point processing, you are processing directly that point of pixels, while neighborhood processing, the transformation function is not just depends on that particular pixel, but is also consider the neighbor pixel as the input of the transformation function. Okay, later we will discuss that in details. Okay, this is the examples of point processing and neighborhood processing that we will cover later. Okay, in point processing it divided into two. One is gradable transformation functions, and then we talk about the histogram processing. Okay, okay, in this syllabus, okay, in this courses we don't cover this one. Okay, we only focus on histogram equalization. And then for neighborhood processing, it divided into two, which is smoothing and sharpening. And then in smoothing you will cover a lot of process, which is averaging, Gaussian, median, mean and max, and so on.